this video, I'll show some examples on how to do power calculations with motors. These examples will be useful in practicing for the FE or PE exam. So example one, let's assume we have a fully loaded 30 horsepower motor operating at an efficiency of 80%. In power factor of 75% lagging. So the question is, so this is example one. Question is, what is the power, the complex power? So again, it's always helpful to do like a little sketch. So I have a motor. It takes an input, so I will call it Pin. It gives us an output. I'll call it Pout. It's operating at an efficiency of 80%, a power factor of 75, 0.75 lag. So I'm giving Pout in terms of horsepower, which is 30. So efficiency, basically you take the what is the output you get given an input. So it's Pout divided by Pin. I know efficiency, I know Pout, I can calculate Pin. So Pin, or the input power, is equal to Pout. So Pout divided by efficiency. So Pn is equal to Pout is 30 horsepower, and I can do the conversion. I know 1 horsepower is equal to 745.7 watts. I would recommend watching videos I made on how to convert from horsepower to watts. Efficiency is 0.80, so horsepower will cancel out. So if you carry out this calculation, you get Pn is equal to 27.96 kilowatt. So we know S, the complex power, is the real power plus J times the reactive power. Again, from the power triangle, which I recommend watching videos I made on power triangle. So this is theta. So the real power, reactive power, and the complex power. We have a power factor equal to 75%, which means the angle corresponding to this power factor is the inverse cosine of 0.75, which is equal to 41.41 degrees. So this theta here is equal to 41.41 degrees. If I do trig, I don't have to memorize anything, just cosine theta is equal to P divided by S. I know the cosine theta is just a power factor, I know P, I can calculate S. So S, the magnitude of S, is equal to P divided by power factor, basically, or cosine theta. So P, I calculated 27.96 kilowatt. Power factor is 0.75. So S is equal to 37.8 kVA. If you want to calculate the reactive power, again using trig, so tan theta, which is equal to tan of 41.41 degrees, is equal to Q divided by P. So Q is equal to P times tan theta, which is 41.41. So P again is 27.96 kilowatts times tan of 41.41 degrees. So if you carry out that calculation, you get 24.67 kVAR. S is equal to P plus J times Q. P is 27.96 kVA, kilowatt, plus J times Q. Q is 24.67, and we know S is kVA. If you want it in polar form, where magnitude is 37.28 and the angle is 41.41 degrees kVA. So that's example 1. Example 2, we have an induction motor. Induction motor operates at an efficiency of 75% and absorbs a load of, or absorbs 90 kilowatts at a power factor of 85% lagging. So question 1, what is the horsepower rating? What is the horsepower? The horsepower rating of this motor. So how would you approach this problem? Again, it's always a good idea to make a little sketch. So I have a motor. It takes an input power. It gets an output power. It operates at an efficiency of 75%. So I'm given Pn, which is 90 kilowatt, and the power factor is 85% lagging, and I'm trying to calculate P out. So again, as I stated in example 1, efficiency is P out divided by P in. I know efficiency, I know P in, I can calculate P out is equal to efficiency times P in. So efficiency, let's see, efficiency is 875. So 0.75 times Pn which is 90 kilowatt. So this comes to 67.5 kilowatt. So P out is equal to 67.5 kilowatt, and I can do conversion. I know 745.7 watt is equivalent to 1 horsepower. So the watt will go away, and I end up with 67.5 times kilo, which is 1,000, divided by 745.7 and times 1 horsepower. So if you carry out the calculation, you get 90.52 horsepower. So that's how you kind of perform power calculations on motors, given, either you are given the input and efficiency power factor, then you calculate the output power, or you're given the output power and you're trying to calculate the input power, or you're given output input, you're trying to calculate efficiency. So by knowing these equations, one thing to keep in mind is efficiency is P out, or output power, divided by input power, and also 1 horsepower is equal to 745.7 watts. So these are very handy or useful equations when you're dealing with motors. That's it for this video. Thank you and have a great day.